Hello everyone, this is video 2-17 to be watched Monday 10/24, and the corresponding homework is page 27, numbers 1 and 3, just two problems. Okay, so for all of the 6 trig functions, sine, cosine, tangent, and their co-functions, there's a formula for the derivative, and same with the inverse trig functions. So these formulas are a little more complicated, and they also need to be memorized. So inverse sine is this one here, inverse cosine right there, inverse tangent, and then there's one for all of the co-inverse functions. Guys, if you're having trouble memorizing these, then you could talk to me about it and we could try to figure out something that works for you. But memorizing really, sometimes it's annoying, but it is a skill, and there are, as you, maybe you're already used to memorizing things, but as you get more and more used to memorizing things, you'll have your own techniques. But if you're having trouble memorizing these, come see me and I can talk to you about like the way I would remember them. Okay, so here we go. Find the derivative of the function below. Y equals arc cosine of 1 over x. Guys, arc cosine is just another way of saying inverse cosine. Okay, so all of the inverse functions, inverse trig functions, if you just put arc in front of it, that's the same thing as saying the inverse. That would, like, with the little -1 notation. Okay, so I look at this and I ask myself, well, I see a cosine, so already I know it's not like power rule, because it would have to be, to use power rule, I would need terms of the form ax to the n, and that's not happening. So I have to use a formula. Well, inverse cosine, that's one of the new formulas that I just presented up here. So there's that. But then I look a little closer and I see another function inside of inverse cosine. It's not just inverse cosine of x, it's inverse cosine of 1 over x. So really I see two functions. I see an inside function and an outside function. The inside function I see is 1 over x, and that actually you can use the power rule on if you write it as x to the -1. All right, so that's how I'll write that. And then the outside function is inverse cosine of blank. Okay, so I'm using the chain rule. The derivative of this is just -x to the -2. And the derivative of inverse cosine, it might take some getting used to, but it is this right here. So I'm just going to write that, but with a blank where there was the x. Okay, so this is -1. It's going to be -1 all over the square root of 1 minus blank squared. Okay? And whenever you're using the chain rule, what goes back inside of the blank? The thing that we took out of the blank to begin with. Okay, so at the very beginning of the problem, before you even took the derivative, what was inside? X to the -1. Okay, so y prime equals, I'm just going to simplify a teensy bit. You don't even have to do this, guys, but I'm going to go positive x to the -2, because negative times negative, and then all over radical 1 minus x to the -2. Okay, so there is that. One more example. So this next one here, this is not like arc trig notation. This is just, plain old -1. I don't even know how to say that, but this is just the normal notation you're used to represent an inverse. And again, I see functions within functions. This is not just a normal 2 times inverse sine of x or something. This is, I see a radical, I see a polynomial. So this is definitely chain rule. So I'm at least going to have one inside function. So I look at it and I say, okay, what's inside of another function? Well, I see 1 minus 2x squared inside of the larger function. But I also see the square root function inside of the larger function. So this is actually a double chain rule situation. Okay, there's 2 inside functions and one big outside function. And guys, I know that this was a source of confusion at the onset of the chain rule, or the derivatives of trig functions. But when you have a coefficient on the trig function, whether it be inverse trig or not, that is going to be part of the outside function. And to take the derivative, we're just going to bring the coefficient down. It's this. So what I'm trying to say is this is not like a product rule situation. Alrighty, so the innermost function is 1 minus 2x squared. What is that inside of? It's inside of blank to the 1/2, the square root part. And that is inside of 2 inverse sine of blank. All right, now we can take the derivative. So the derivative of this part, the innermost function, is negative 4x. The derivative of this part is 1/2, so I'll go times 1/2 blank to the negative 1/2. And what goes back in that blank? What was inside to begin with. So 1 minus 2x squared. And then the derivative of this is what I was saying earlier, sort of clumsily, but we're just bringing down the coefficient, which is 2, and then taking the derivative of that, okay? So the derivative of inverse sine, I have to look at my formulas. It's this one right here. So it is 1 over square root of 1 minus blank squared. All right? And what goes back in the blank? Both of the old insides. Okay, so this is going to go back in, and this is going to go back inside of that. So I'm going to convert this back to radical notation. So this is, so that went back in, and then this goes back in. 1 minus 2x squared. Now, I'm about to write the final answer. You could leave it like this, guys, but it's pretty easy to clean up, so I'm going to. So y prime equals, I've got, so this is 2 times, no, it doesn't work like that. Okay, so these are canceling, right, so I'll just have in the numerator negative 4x blank, I don't know why I put a blank, but 1 minus 2x squared goes inside, all over radical 1 minus, now I'm squaring a radical, so I've just got this, okay? And then I'm going to go just a teensy bit further, but you don't even have to do this, guys. So this is negative 4x 1 minus 2x squared to the negative 1/2. And then this is radical 2x squared, which, you can take the x out, but I'll just leave it like that. Whoops, I crossed off the exponent. Okay, guys, so I will see you later. The corresponding homework is page 27, numbers 1 and 3, and see you soon. Bye-bye.